The Filter project is a collaboration between the Victorian Department of Transport and Planning, the iMove CRC, and RMIT University that aims to provide a robust, evidence-based approach for evaluating urban renewal precincts, starting with Fishermans Bend in Melbourne. Fishermans Bend is made up of 5 distinct precincts, each planned with its own clear identity and role: Montague, Lorimer, Sandridge, Wirraway, and the Employment Precinct. Sandridge, Wirraway, Montague, and Lorimer are mixed-use precincts, which sets them apart from the Employment Precinct. Together they form a large urban renewal area, but each precinct has different expectations for built form, job targets, housing densities, dwelling types, commercial growth, and so on. Evaluating urban development in precincts like Fisherman's Bend relies on the synthesis of significant volumes of complex and dynamic data on transport, housing, employment, environment, and more. This data is often collected at different scales, geographies, and frequencies. The main approach used in today's urban information portals is to first harmonize all the data into a single, standardized spatial framework, such as statistical areas, mesh blocks, or destination zones. However, harmonization requires complex and bespoke spatial analysis by statisticians or geographers for each indicator and each precinct area. And in many cases, harmonization may not be possible. As we can see from this illustration, statistical data aggregated by region, such as official statistical areas or suburb boundaries, cannot easily be transformed to fit different areas, such as precinct boundaries. That means the boundaries for the urban development indicators usually don't match the boundaries for precincts, making it difficult to get a clear, unified picture of what's changing or how interventions are working. The filter demonstrator tackles this challenge with a unique approach. Instead of trying to harmonize all the indicators to a single statistical framework, we embrace the diversity of the data. We think of our diverse indicators as a patchwork. Each data item retains its own geography, but advanced AI techniques enable us to stitch these pieces together, creating a coherent narrative that helps decision makers understand the bigger picture. This narrative-driven integration is the key innovation behind the filter demonstrator. Our demonstrator interface was developed from design first principles by the RMIT research team in collaboration with the Department of Transport and Planning. Throughout development process, we incorporated feedback from DTP stakeholders to refine the interface and ensure it is intuitive, accessible, and maximizes utility for real-world decision-making. You can see here one of the early design sketches with 3 distinct interface areas used to provide the stitching. Let's step through these 3 main parts of the filter demonstrator in turn. In the center, the map view displays the precinct boundaries together with the patchwork of indicator data. The precinct boundaries are in the foreground, picked out with the same colors used in the Fisherman's Bend framework, which sets out the overall precinct plan. Each indicator, whether it's transport, housing, or environmental metrics, is visualized in its native scale and geography, providing a rich, multi-layered perspective on the precinct. The background map and indicator data itself is intentionally achromatic to avoid misleading interactions with colored precinct boundaries. The map is interactive, showing more detail when users hover over a specific area, such as any change over time. Here you can see the change in total jobs over time in a destination zone within one of the precincts. On the right, the narrative view is where Filter's AI capabilities shine. Here, authoritative indicator data is stitched together into a human-readable story about the precinct. This narrative aims to help users make sense of complex, fragmented data, highlighting key trends, insights, and areas for action. Selecting a statistical unit in the map view brings up a narrative to accompany the data for that area. The narrative is AI generated, but bold items in the narrative come direct from the precinct plan or the database itself, ensuring the contents are trustworthy and authoritative. Selecting a precinct brings up a different narrative that weaves in data about the different statistical units that overlap with that precinct. Highlighted text items are hyperlinked, enabling feedback loops for users exploring changes to the map and narrative associated with different links, such as data for different years. The information icon at the top right allows users to select from 11 different indicators already available in this demonstrator, 2 of which have been augmented with further drill-down comparisons. The AI search bar also enables novice users to identify indicators that might relate to their interests, even if they don't know what specific indicator names mean. For example, by searching for economic, the AI tool suggests 3 possible indicators that relate to industry and jobs, even though none of these indicators refer explicitly to economy. Hyperlinked breadcrumbs above the narrative help users keep track of where they are in their exploration and navigate between narratives. A summary of the current view can always be exported to a document for later analysis or integration with other reports. Our demonstrator includes 3 different export contexts, enabling the capture of dozens of different views of the data and associated narratives as distinct reports. Finally, on the right, the context view supports deeper insights by enabling comparisons, not just between visible data, but also with invisible data that may not be directly mapped. This helps users understand relationships, gaps, and gain insights that might otherwise be missed. At the top, the classification that relates to the mapped indicator is provided. Different classifications will often provide quite different impressions to the user about the patterns in mapped data. Potentially, any classification may be used during indicator preparation instead of the equal interval classification used in the demonstrator. Below this legend, a narrative helps to provide more information about that classification, setting the data in the context of other urban areas, or highlighting changes over time. 2 indicators also include data graphics, such as this chart, to show more statistical detail about the context in comparison with other urban precincts. While only a demonstrator, Filter provides a clear direction for the development of a practical, innovative, and operational tool for precinct evaluation. The demonstrator has been implemented on a robust AWS platform and is available for testing by a wide range of stakeholders. We believe the filter approach can empower stakeholders to navigate complex urban data, support evidence-based decisions, and set a new standard for precinct evaluation in Victoria, nationally and internationally.